Okay, so I'm going to do 4A on page 44. You are given tungsten oxide and hydrogen gas yields tungsten and H2O. But what they tell you is that you've got 41.4 grams of tungsten in your actual yield, so that's what comes out of this reaction. They want to know what the percent yield is, so you have to figure out what the theoretical yield is. And anytime you need to find the theoretical yield, you have to use stoichiometry to do it. So what they give us is the mass of the tungsten oxide. So stoichiometrically, we need to determine what the theoretical yield would be. So you have to find the molar mass of tungsten oxide by looking at periodic table. We have 3 parts oxygen. It's 15.99 times 3 plus tungsten's molar mass, which is number 74, so 183.84. You get a molar mass of 231.81 grams of tungsten oxide in 1 mole tungsten oxide. Grams cross off. And now we're left with moles of tungsten oxide, and we want to get from tungsten oxide to tungsten. So we know anytime we're getting from one part of a chemical reaction to another, we have to use the molar ratio and look at the coefficients. So it's a good time to double check that this equation is balanced. 1 tungsten, 1, 3, 3, 6, 6. So we're good. So the coefficient for tungsten oxide is non-existent. So there's an understood 1. And we're going to tungsten, which also has a 1. And now we need to take the last step, which takes moles of tungsten to the mass of tungsten, which is our end goal here. So we look at our periodic table to see that the molar mass of tungsten is 183.44 grams of tungsten. On your calculator, you're going to multiply by anything on the top, divide by anything on the bottom. So we find the theoretical yield with 3 sig figs to be 55.0 grams of tungsten. So then we are going to take this value, and don't use the calculated value, use your value as sig figs. So your percent yield is going to be equal to your actual yield divided by theoretical times 100. So our actual is what they told us came out of this reaction. So it's 41.4 grams divided by the theoretical is what we found, 45.0 times 100. You really feel it. And you get 92, but we had to use 3 sig figs. So 92.0% yield. Percent yield is your unit for this. You need to include that in your answer. A number by itself doesn't mean anything. All right, should we move on to B? B is asking you if you have a percent yield of 92% for a different reaction, and you have 3.7, slide up so you can see better, 3.79 grams of tungsten oxide to begin with. How many moles of tungsten do you have? So this is what we're looking for, given this, and this in our relationship is going to be that percent yield written as a number is going to be equal to the actual yield divided by theoretical. So as long as I have any two, I can figure out the third with theoretical. A little bit of algebra. So my percent yield as a number is 0.92. So you just divide by 100 to get it back. I want to figure out how much actually is there. So this is what we're actually looking for to determine that. And then we need to run the theoretical through stoichiometry, which means I want to take tungsten oxide and convert it to moles of tungsten. If you wanted to, you could have converted it to grams. The reason I'm converting to moles is because that's what I'm actually looking for. So if my theoretical is in moles, then my actual would come out in moles when I run my numbers. So just like always, I want to get grams of tungsten oxide at bottom. And I have mine from above to be 231.81 grams in 1 mole. So my grams of tungsten oxide cross off, and I have moles of tungsten oxide on top, so I have to put it on the bottom here. Now the whole goal is to get from tungsten oxide to tungsten, so I need to find what is the molar ratio. And again, that is just looking at the coefficients from the given chemical reaction. And they are 1 and 1 still. So 1 and 1. Now moles of tungsten oxide cross off, and I need to convert this tungsten to mass in grams. The only relationship I know is by looking at the periodic table. And it's also in the previous problem if you want to just look above. So 183.44 grams of tungsten. Just type it in your calculator. 3.79 divided by 231.81 times 183.44. Oh, this is why I was only going to go to moles. I was going to stop here. So I'm actually going to scribble this guy out and stop at moles of tungsten, because that's what they were actually looking for. If they were asking for grams, they could have done that one. Or you could do that one and then convert back, but that would be silly. So let's actually go 3.79 divided by 231.81. It's 0.0, and we've got 3 sig figs, so 163 moles of tungsten is my unit from here. All right, now what I want to do is I'm still looking for the actual, and this is just the theoretical yield. So now I have theoretical and I have percent yield, so I can calculate my actual from this equation. So 0.92
What do you mean for possibilities?
Equal to 0.0163, and you will solve for x, and that will give you your answer.